So I'm going to be talking about problem 2 on exam 3. And the first part of the question asks you to mark the direction of the currents through the resistors shown over here in the circuit. So you know that it's going to go from the positive to negative direction. So over here, R1 is going to go towards the negative end of the voltage. So you have I1 right here. And then I guess if you start from the positive, you're going down this way. I2 right here. I3 right here, still going towards the EMF A. And then over here, you can see that I2 splits into I4 and I3 and connects back to go into I1. But it doesn't really matter how you draw these arrows as long as you're able to justify it in the later parts of the problem. So I guess if you wanted to put the I4 going up, that's what would be different in your node rule equation. And that brings us to part 2. So part 2 of this question asks you to write down the node rule equation for this circuit. And basically the node rule equation is that in a steady state, the currents are constant and no charge accumulates in or on the wires or at the junctions. I mean, there could be like a tiny bit of charge on the wire, but in steady state, that charge is not going to be increasing or decreasing. And the charges on the capacitors are also constant. And so that leads us to the node rule, which is the sum of the currents in equals to the sum of the currents out. So in this case, it actually asks you to do the node rule equation relating I1, I3, and R4. The question doesn't ask for I2. So you know that I3 and I4 connect up to be I1. So over here, you know that the answer is I1 equals to I3 plus I4. Now, say that you drew your I4 arrow going up, then it would be different. It would basically just be opposite. Well, it would be, yeah. And then the next part of the equation, or the next part of the question, sorry, asks you to write down the 3 loop rule equations. And then so the loop rule has to do with the voltages, right? And you know that V equals to IR. So let's see, the first one, we can look at the left loop right over here. So the loop rule equation for this one, you can start at EMF A. So we know EMF A, go down. So we know that minus I1, or I2 R2 minus I3 R3, and back to EMF A. So it would be minus I1 R1 as well. So for the left side, it would be EMF A minus I2 R2 minus I3 R3 minus I1 R1 equals to 0. And then you can look at the loop that goes around the whole circuit. So starting at EMF A again, you know EMF A minus EMF B minus I4 R4, and then back to minus I1 R1. So then you have EMF A minus EMF B minus I4 R4 minus I1 R1 equals to 0. And then if you focus on the right loop, right over here, so you start at EMF B. So you have EMF B, so you want to go from the positive end to the negative, right? So you have EMF B minus I2 R2 minus I3 R3 plus I4 R4, because you're going the opposite direction of the current, equals to 0. So for that one, you had EMF B minus I2 R2 minus I3 R3 plus I4 R4 equals to 0. And then you could actually still make 2 more even though the question, or even though the problem only asks for 3. So we can go ahead and write them down. So the loop on the top right here. So you have this loop right here. So you can do EMF B minus I2 R2, and then if it goes this way and back here, it would equal to 0. So that's another one. EMF B minus I2 R2 equals to 0. And then you also know that this loop right here. So we have I4 R4 and I3 R3. So it's going this way. So you can say, well, it's minus I3 R3 plus I4 R4, because once again, you're going against the direction of the current. So it's I4 R4 minus I3 R3 equals to 0. So the next part asks you to use these loop rule equations and try and solve the equations to find the value of the current for I1, I2, R3, and R4, or I4, sorry, and it gives you values of voltages to use. So it says that EMF A is equal to 10 volts and EMF B is equal to 5 volts. And then it also tells you that R1 and R2 are both equal to 100 ohms, and then that R3 and R4 are both equal to 200 ohms. And then obviously to go about this problem, you want to choose the equations that are going to give you the most simple answer, right? Unless you want to sit there and take a really long time by choosing the hardest equations you can to solve. So the easiest to choose would be this one because it looks really small. So let's start with that. So we know that, so now basically just solve using systems of equations. So we know that EMF B minus I2R2 equals to 0. Bring this to the other side. So you have EMF B equals to I2R2. And then you can basically solve for I2. So divide both sides by R2. And you know that I2 equals to, so we have the value of EMF B being 5 volts over R2, which is 100 volts. Or 100 ohms, and you know that equals to 0.05 if we put it in your calculator. So that's the value of I2. And then you can use that value to find the value of the other ones. So let's see, the next equation that's also short that we can use is this one right here. So we know that I4R4 equals to I3R3 if you bring the I3R3 to the other side of the equation. So we know that they're going to be the same value. And then, so this equation right here integrates a value that we know, another value that we know, and then two values that could be equal to each other so we can use to find. So let's use this one next. So we know that, sorry, it's shaky, EMF B minus I2R2 minus I3R3 plus I4R4 equals to 0. So using that, you can plug in what you know and solve. So you know this value right here, you know this value right here. So you're basically looking for one of these values, but you can find both. So we know that I4R4 equals to I3R3. So actually, just kidding. That would still give us the values that we already know. So let's try and pick another one to use. So we know that using the node rule equation that we defined in part B, I1 equals to I3 plus I4. So since I3 and I4 are equal to the same thing, we can have I3 plus I3 equals to 2I3. Sorry, just a second. And then, so that can also help us solve it in moving on furthermore. So then you can use this equation, actually, the one that we used to find around the whole perimeter right here. So using that equation, we can, here, let me just rewrite it down here. So EMF A minus EMF B minus I4R4 minus I1R1 equals to 0. And then using that equation, we can plug the values that we know in. So we know that I1 is equal to 2I3, which we found out using the node rule right here. So we can go ahead and plug that in, and then we know the values of EMF A and EMF B, and then we can use that to find the value of I4R4, since we're also given the value of R1 and R4. So once you solve that in, it'll look like this, minus EMF B minus I3R3 minus 2I3 times R1, which we substituted in from the node rule equation, all equals to 0. And then when you simplify that, you get the value that you're looking for. So you bring everything else to the other side. You'll end up with I3 equals to EMF A minus EMF B all over R3 plus 2R1. And then when you plug in the values of EMF A, EMF B, R3, and R1, you'll end up with, here I'll just plug them in, 10 volts minus 5 volts over, what was R3? Okay, minus 200 ohms plus 2 times 100 ohms. So that'll give you a value of 5 volts over, what's that, 2 times 200, so 400 ohms, which will be approximately 0.0125 A. So that is the value of I3. And then you know that, oh my God. You know that I3 is also equal to I4, so since they're both equal to the same thing. And then for the last part, you can still use this node rule equation to figure out the value of I1, because you have I2 right here, you have I3, I4, and then to find I1, you just plug in, you just plug in 2 times I3, so I1 equals to 2 times 0.0125, and then you end up with 0.025 angstroms, or sorry, 0.025. Okay, and that is the answer to I1, and that is how you do problem number 2 on exam 3.